Hello, Sas here. This is a video lesson relating velocity and acceleration. And then afterwards, we're going to take the opportunity to also relate it to position. This is going to be a sophisticated analysis of graphs and how having one can lead to the others. I'm going to start with a velocity graph. The velocity graph will be piecewise, constant linear piece, a constant piece, another constant piece, and then something a bit more sophisticated, a parabolic piece or a curve that we're going to deal with. Reference points, we're going to say the graph starts at A, transitions at a piece at B, and C and D has this minimum at E, and then ends at F. And what we're starting with is velocity as a function of time. And we're going to relate this to acceleration. Acceleration is the rate of change of velocity. We're going to have the same intervals on the horizontal time axis. And just like velocity is a rate of change of position, acceleration is a rate of change of velocity. So the same reasoning applies when we take a velocity graph and we think about the rate of change of all these pieces and graph that rate of change. On the interval from A to B, velocity is constantly positive, and the rate at which it's changing is constant. It's constantly going up. We could think of the slope of this line as 1. Rise over run, we have an acceleration of 1 because the line along AB has a slope of 1. So we have a constant acceleration of 1. On the interval from B to C, the slope of this piece is 0. It's a horizontal line. Velocity is not changing. It's like being in a car and going the same speed for this interval of time. We do not accelerate. We can show that as a 0 acceleration on that piece. Now, from C to D, our velocity jumped from being positive to negative. Positive velocity might mean we're moving forward. Our position is going up. Negative velocity means we're going backwards. Our position is decreasing. But the acceleration remains 0. There is no change in velocity during this time. So we have, again, another constantly 0 acceleration piece. On this curve, it's much more sophisticated. So we're going to think of velocity along this curve and then how it might relate to acceleration. Velocity at the beginning, at the interval moment D, velocity is positive. That means our position is increasing. We're moving forward. But our velocity decreases. We're moving forward, but our forward motion is slowing down. And then, when we transition into the negatives, we're moving backwards. And our backward motion is speeding up. So from D to E, we start by moving forward, but we're slowing down our forward movement to the place we stop, and then we start going backwards at a higher and higher rate. That is accelerating negatively during the interval from D to E. From D to E, we have negative acceleration the whole way, but not a constant negative acceleration. Our acceleration, the rate at which we are changing our velocity is higher in the beginning. We have a more intense negative acceleration at the beginning of this interval because the velocity goes down more than it goes down at other places. So again, starting at D, our acceleration is negative because we're slowing down and then going backwards. But the rate at which we are slowing down, or the rate at which we have negative acceleration, is more intense at the beginning until it gets at point E to be 0. Graphing that, I could say my acceleration is negative and is negative the whole way, but the acceleration gets less and less negative. And at E, we're moving backwards. But our backward movement is slowing down as we continue in time. At E, we have the most intense negative backward movement. And even though we continue to move backwards while we're under the t-axis, the rate at which we're moving backwards gets less and less. Because we're stepping on the gas in our car, we are accelerating, we're trying to move forward, we're accelerating positively. Our backward movement is getting less intense until our backward movement comes to a stop, and then we start moving forward. And we start moving forward at a higher and higher rate. So on the interval from E to F, we have positive acceleration. We're stepping on the gas, we're slowing down our backward movement until we come to a stop, and then we move forward, and then we move forward faster and faster. Positive acceleration. But not at the same rate. Our acceleration gets more and more intense as time goes on. That's reflected in this linear piece. Notice now that we've completed the acceleration graph that for linear pieces, we have constant acceleration. For constant pieces, we have 0 acceleration. And for a parabolic piece, we have linear acceleration. There's a mathematical relationship there. Let's wrap this up by talking about how we can make a position graph from this information. This is a fairly sophisticated project. It requires reflecting quite a bit and reasoning the concepts behind these curves and what they mean to get the position function as accurate as possible. So this is going to have the same horizontal time axis. We're going to graph position as a function of time based on this velocity information. So in this first interval, we're going to start our position somewhere. There is no information in the velocity or the acceleration graph that lets us know where we should start our position graph. I'm going to choose the origin, but that's an arbitrary choice. I could start my position anywhere. What we care about and what we have information on is how the position is changing from that starting point. But we don't know where to start. I'm just going to choose the origin for this example. If I start my position here, then velocity that is constantly positive but getting more intense means that my position is going to go up. I'm driving away from my starting point. But the rate at which I'm driving away gets more and more intense. That kind of curve, or that position, is going to be reflected in a curve that curves up. We are constantly increasing our position, but the rate at which we're increasing gets more intense as our velocity increases. Then on the interval from B to C, the position is going to keep going up. It's going to increase because we have positive velocity, but the rate at which it's increasing is going to remain constant on that interval. Constantly up, constant change in position. This is not a curved piece. Then we're going to go backwards. We're immediately going to decrease our position at a constant rate, but not as intense of a slope as this positive piece. We're going to go backwards at a lower rate of change. This curved piece here in velocity is going to get quite sophisticated when we draw the position, which is also going to be curved, but not in the same way. So let's think about this velocity piece and how it relates to position. Well, at the beginning, D, we have a positive velocity. And that velocity is going to be changing quite intensely. We're going to be going up. But the rate at which we increase is going to slow down. As long as velocity is positive, we're increasing position. We start with a pretty intense increase, but then slow that increase down to 0. That looks like a curve like this. This curve shows us increasing the whole time, but the rate of increase is slowing down until we come to a stop where the velocity is 0. Then, when the velocity is negative between these 2 points, we're going to go backwards. But we're not going backwards at the same rate. We're going to have very slow backward movement, and then our backward movement is going to get pretty intense here. And then our backward movement is going to continue, but it's going to slow down until we stop. So we have backward movement that changes from being slow to fairly fast, back to slow again. How do we capture that in a curve? We know that we're going to constantly go down, but a slow at start, then more and more intense backward movement until we're moving backwards at the highest rate. And then our backward movement continues, but it slows down to a stop. And then at this place here in the velocity graph, we're going to begin our forward movement again, which means that our position is going to go up. It's going to go up a little bit at the beginning and then go up more intensely at a higher rate to finish. Again, that curve looks like slow positive change that intensifies. And we finish. Take a look at the relationship between the pieces of the velocity and the pieces of the position function. A linear velocity piece made this kind of curve, which if we had the mathematics, would be parabolic. It would be a parabolic piece. A constant velocity became a linear position. This constant velocity piece also has a linear position piece, but negative slope. And this quadratic curve piece in velocity became a cubic piece in the position graph.